A nested loop structure is simply one loop running inside another loop. And when that happens, the inner loop will execute all of its iterations each time the outer loop goes through one iteration. So I have here a little example that I created in Visual Basic. And this is the code for the demonstrate button. And this code generates the output that we see over here on the left-hand side of the application. And it's generating some numbers in a list box. There are 9 numbers that are generated, and that's because each loop executes 3 times. And so each time through the outer loop, which is the I loop for I equals 1 to 3, the J loop goes from 4 to 6. So that J loop actually executes 9 times, the I loop executes 3 times. There's a couple other lines here you'll see grayed out. Those are simply demonstrating the changing values of I and J in the output in this list box over here. And I just did that for the sake of explanation. Let me color code these 2 loops so you can see these. So we have that yellow loop inside the pink loop, and that yellow loop is going to execute 9 times, 3 times for each time the pink loop executes. When the loop first executes, I is going to be equal to 1, and then inside that it's going to do the for j equals 4 to 6. J is going to start out equaling 4. And our output, which is k, is I times j, so 1 times 4 is 4. In the next iteration of our j loop, j will be 5. And our output will be 1 times 5, or 5. And then it's going to do a third iteration in which j is 6, and 1 times 6 is 6. That's our output. So you'll see that in the first 3 values in our list box are 4, 5, 6. J now is equal to 7, and so that's going to be outside the range of that inner loop. That's going to force the execution to that next line for the outer loop, and I will then become 2. And within that outer loop, then we execute the inner loop again for j equals 4 to 6. So j is going to start back over at equaling 4, and 2 times 4 then is 8. Next iteration of the j loop, j is 5, and 2 times 5 is 10. And the next iteration, j is 6, and 2 times 6 is 12. And that's our next 3 lines in our output, 8, 10, and 12. Then in the next iteration of our I loop, I equals 3. Once again, we will execute the inner loop completely 3 more times. So the first time, j is set to 4. 3 times 4 is 12. Then j becomes 5. 3 times 5 is 15. And then j becomes 6. And 3 times 6 is 18. J has now reached its upper limit for that inner loop. It's going to kick outside of that inner loop and go back to the outer loop. But we've reached the upper limit of that outer loop. And so our execution is going to continue with whatever comes after the next statement for that outer loop. And our nested loop structure is complete. Here is the same structure done in C#. Our outer for loop starting with at I equaling 1 and commencing as long as I is less than or equal to 3, and each time through the loop we're incrementing I. And then our inner loop, j is going to start out the value of 4. It proceeds for each iteration while j is less than or equal to 6 and increments once through each iteration. And our same output. K equals I times j. All right, well, let's watch this program run in C#. I'm going to go over to the code, and I'm going to set a breakpoint in my outer for loop. So it's going to stop executing there, and then we can step through it line by line. So I'm going to right-click, choose breakpoint, insert breakpoint, and then so we can also see the output in our program while it's running. I want to refresh the screen occasionally. So in my inner loop, I'm going to add a this.refresh method. This, of course, referring to our main form. And so we'll refresh it or redraw it each time at that point in the loop. Let me go ahead and I'm just going to scroll this up a little bit. And let's go ahead and start debugging. I'm going to click the demonstrate button, And so what happens is the code now has stopped executing on that line, and I can step into the next line of code. So I can go line by line simply by clicking the step into or pressing the F8 key. And let me also bring up our locals window so we can watch the value of our local variables. So you'll see I, J, and K there, and we can watch these values change as the code executes. So again, I'm going to continue to step into, so I is 1, now it's getting to J, J starting out as 4, checking to see if it's less than or equal to 6, and then K is going to equal 1 times J, and we'll see in the locals window there that K becomes 4. Now it's going to add that to our list box. We're going to hit this dot refresh, so we're going to see the screen redraw, and we see 4 pop up over here in our list box. Now we're hitting the end of that loop. We're going to go back up and increment J, and so J now is going to become 5. 5 is still less than or equal to 6, and it's going to continue executing the contents of the loop. So K is going to equal 1 times 5, now becomes 5. We're going to add that to the list box, refresh the monitor, and there it is. So I'm going to continue stepping through this. J becomes 6, and K becomes 6. Now J is 7. It's outside of that range. It's going to jump down past the end of that inner loop, and now we're back into the next iteration of our outer loop. We're going to increment I. I becomes 2. We're comparing its value to 3. It's still less than or equal to 3. So we're going to execute the loop again, and we hit the 4, and now we're going to execute this J equals 4. So J is back to 4, checking it against the value of 6. It's less than or equal to. And we're going to continue executing this inner loop now. So we have K equals 1 times J, or 2 times 4 is 8. And we're going to see that value pasted into our list box. J becomes 5, K becomes 10, J becomes 6, K becomes 12, and that is displayed. Now J goes to 7. It's outside of the range. We're going to exit that loop, and we're back into the outer loop where I is incremented. I now becomes 3. It's still within the range. And we reset J back to 4 and go back through that loop again. So 3 times 4 is 12. J becomes 5. 5 times 3 is 15. That's added to our list box. J becomes 6, still within the range. 6 times 3 is 18, and that's added to our list box. J becomes 7, that's outside of the range. So we're going back to that outer loop. I is incremented to 4, and that's outside of the range, and so the execution then continues with whatever's after that outer loop. There's no more code there, so our sub-procedure is done running, and we have our generated output. Of course, you always want to remember to remove the breakpoint once we're done. I'm going to stop my program. Once everything looks good, we're going to remove or disable and delete it, delete our breakpoint. And now my program, if I were to run it again, we wouldn't step through that code each time. Just click demonstrate and we get our output.